than his legs, right? Then what will happen? Eventually the body will get elongated. So this is a kind of all those theories. This has not been proven as such, but these things generally happen. Now I will try to explain how initially the black hole got discovered. Let me see if I can do it with MS Paint quickly, so that if you can understand. Right. Where is my mouse? Okay. Okay. So what happened is, let's say this is a, I will just say this is a black hole, right? Um, Maybe I will draw with this. So this is the black hole, right? And sorry. So this is a black hole. Now what happens? Say I have a star here, or rather I will say the star is actually here. Right. So what happens? And say this is your this is our planet. This is
Good
our
afternoon, sir.
good afternoon. Good afternoon. Yeah. Who is this? Sorry, I could not see.
Aditya, sir. Aditya.
Aditya. Oh, Aditya. Yeah, okay. Great. You're here. Good. You
Sorry,
have
sir, I was late because I have some functions in the home. That's why I couldn't be at
okay.
the right.
No worries, Aditya. I am just trying to explain what a black hole is all
Oh,
about. How a black hole got discovered actually initially. The first. So after that, X-rays and all those things, ideas came later. But how? So guys like Aditya, Sori, can everybody? Can you see that this is a star? This is a black hole, and this is the our art. Right. I will just mention here. Right. So this is our art where our telescopes are there, and this is more of a, this is a black hole. I mean, I just am saying how the black hole I mean how the black hole got discovered when initially in the first place itself. And this is a particular star. This is a star. Just take any star basically. So what happened? So we generally know like light travels. So when this star is emitting light in a straight line, right? So the black hole is such a, the gravitational pull of the black hole is such huge that this actually this light actually bends. Sorry, okay. You can see here. So this light actually eventually bent out and come reach to our surface like this. Similarly, the same star, when the star is giving light, right? Like this way, the and light will flow. Now, what will happen? This one will also get bent into and it will reach here because of the gravitational pull of the black hole.
sir.
Now, if you, yeah, tell me.
Sir, uh,
Yeah.
as you may also know that there is a black hole event horizon in the around black hole event horizon, sir.
Black hole event horizon. What is that?
Uh, a place which is in surrounded by black earth. A black hole is in the middle of that event horizon, and event horizon surrounds black hole, and from that horizon nothing can pass through. Nah, sir.
Yeah, that is there. But all I'm saying is that this horizon is, these lights are going far away from that. This is crossing the horizon,
Oh,
right? This is, so what happens is that
okay.
basically, I mean, just I'm giving. So this star is here. I mean, this coming. This star actually, or let's take this way. The star is giving the light not even so close. It is going like this actually, for example, right? I'm trying to say. But this gravitational pull of the black hole will pull and make it like this, right?
Okay.
I mean, I'm trying to say. Now, what will happen? Why? How? I mean, I'm just saying how initially the black hole got discovered, right? Now, when you
Yeah.
are observing from here, you know and you believe, right, that light travels in a straight line. So, what you
Yeah.
will do? You will project this line, and you will, sorry, you will project this line, and you will see this one, right? And you will also project this line, the other line, because the light is coming this way. You will, give me a moment. You will project this line and assume the, oh, shit. project this line and see that the light is coming this way, because you will not know the light has bent in between. So what will happen? You will observe the same star here also and here also, the same star, because you when you were looking into this, right? Because the star is actually on the back of the black hole. So what will happen? You will see the same star is present at, this is say location A,
Yes, sir.
and same location B. So this is how it got discovered. So how that is possible? The same star can present in two different locations. I mean, there is enough mystery in the universe. I mean, this is just the tip of the iceberg, or what is saying, nothing like that. But this is just so. Then they realize that the light is getting bent by the severe gravitational pull of the black hole.
Yes, sir.
After that, yes, that horizon what you're talking about, yes, that's a good, I mean, so this is a thing like Aditya, for the time being, Aditya, Khyati and Sorik, like I understand that you guys have a special interest on that, so we need to do a little bit deep research, which I think for the other students, which may not be uh, that interesting, because they have some different interest may happen. I'm not too sure. If they are, then fine, all we can do, so we can do deep study, and I like to know individually that what you know and what you don't know, so that I can get try to find out the right answer for you guys. I mean, basically, if I teach you the basics and you know more than that, then there is no point. And the other thing, if I teach too high, too detailed level or high level things, then it may not be helpful for others who just want to understand the basics as of now,
Yes,
right?
sir.
So that's the reason I'm saying, like, maybe Shorik and Aditya will definitely stick together. And if any one of you are also interested, we'll make a small group, maybe a WhatsApp group we'll make, and we'll discuss in more detail and do maybe a lot of try to do more lot of research and share our ideas, right? Share
So,
our thoughts. Yeah, go ahead.
so one last question, sir,
Yeah.
regarding black hole.
Yeah.
Uh, if you may know that black holes are very massive in size, and even one which is making our galaxy stable, the Milky Way galaxy, even
Hmm.
that also a black hole in the middle, at the center of our galaxy, right?
Correct, correct.
And what if the black hole was size of a nickel ball, like a
Uh-huh.
coin? What if
Hmm.
the size of a coin, and uh, take would it crush Earth, or would it simply get dissolved by the Hawking radiation?
No, why you're saying that it will get dissolved by the Hawking's radiation?
Because it's because of its size. Because black holes also lose their mass due to Hawking radiation. But I don't have much knowledge about Hawking radiation. But I know at least this much, that black hole lose size due to loses mass actually.
Okay, okay. So the thing is that I think because I understand that it loses its mass, but I undoubtedly it may not lose its energy, right?
Yeah.
So the more it is getting denser, the more at one point it will also suck more. I don't know, maybe it will. So there is another thing that two stars also collide in the supernova explosion, so the two black hole can merge together. There is also, if you know, there some phenomena happening in the universe where
Yeah.
two black holes are merging together and create another black hole, massive black hole,
Yeah.
because of the gravitational pull. Right. So again, so these are very good points, and I think this needs a little bit deeper understanding, which which is quite. I understand for you and Shorik, this is quite an interesting topic, but for others, I just want to mention, if they, I'd like to definitely will all your questions will be answered. Honestly speaking, I also have very limited knowledge of space, and I know on the basics of things what is happening. But again, we can do together research, especially with the URI Space Agency, and I can also get you answers from the New York Academy of Sciences, where they have the a lot of theory papers and all those things are there. Right. So definitely, I will get your answer. But I think to answer your questions, the Hawking radiations, when it becomes too small, if it is small, the more smaller in size it is getting, right? So based on that, if you can understand, as I mentioned, like just the the force, the gravitational force, F is nothing but F is equal to G capital M small m. Small m is your target, that say whatever is pulling. So m is, let's assume the m is the mass of the what I'm trying to say, mass of the black hole, right? Then where is it? So by you have the r square basically, right? R square. So this r square, what I'm trying to say is this r square, and now if your size is getting smaller, that is the r is becoming smaller and smaller, right? That means limit tends to 0. So if limit tends to 0 and this m is growing high, you can imagine that it is the force is actually eventually going to limit tends to infinity, right or not? Sorik,
Yes, sir. Yes, sir.
right?
Yes, sir.
Because m is going high because of the collapse. I mean, collapsing all the molecules. I mean, converting the new hydrogen protons to helium and making a atomic mass going up. The aim is going high, and also the size of the it is becoming so dense, the size is reducing. So basically, the F is going to infinity. So if the F, the gravitational pull, is going to infinity, eventually you are actually becoming such a powerful that you may attract all the stars together into your place. So that's the reason why the black hole is. And as you rightly said, Aditya, like I agree on you that this is something called a how what you're talking about, that the to stabilize the galaxy, the black holes are required. That is called the gravity assist. Something called the gravity assist. Maybe I will not talk today about it. I don't know stars and galaxies. I don't have. I mean, maybe at this page I will share with you guys to make a better understanding. So this where you can get the maybe I'll just say this is called the what you're talking about is called the gravity assist, right? So there's a lot of lessons here. Wait, the search button is not coming. I will say wait a second. Mm, even I go to Big Bang. There's search button. Okay, I got it. Sorry. So this is called a gravity. Is my screen visible? Wait, gravity assist. Yes. So this when you talk about the gravity assist, like how gravity assists the stability of the all the galaxies, right? So this I mean gravity assist. This is I mean even a spacecraft is pulled by the gravity assist basically. So I'll talk about all those things maybe later with few of you guys, not all, because it may be too high for them to go through, or it may be if it is easy, then please join our group. I will ask Pascal to create a group between Aditya, you, and Shorik, and whoever is interested for the space technology. Right? So that is what until now. The other question that you raised, Aditya, maybe just to answer that, how a rocket is launched. I mean, to uh, how does a rocket work? Right? It works with the same principle of the Newton third law. Every action has a reaction, basically. Right? So right. So just to give you an idea of how does the rocket work, is it works with the principle of every action has a reaction. Like if you have seen that example what it is giving here, like if you have a balloon and you just loosen the balloon, right? The air will come out of the balloon and the balloon will run up, right? Have you seen that it goes up, right? So have you noticed that if you let air out of a balloon, the air goes one way and the balloon moves in the opposite direction. The rocket works in much the same way. Exhaust gas coming out of the engine nozzle at high speed pushes the rocket forward. So most modern launchers such as Europe's Ariane 5 are very sophisticated and weigh hundreds of tons at liftoff. Most of this way is fuel, such as liquid hydrogen and liquid oxygen. Rockets need so much fuel in order to overcome Earth's gravity. The escape velocity I talked about just a few minutes back. Like only so that much of speed is required, so that much of fuel is required. Now the more you, so if you see, because R is very at the Earth's surface, the R is 0. So actually, the lift requires the escape velocity is infinity at that point of time. So you need such a thrust that you go out of the Earth's surface. The more you move up, the r or the distance between the two, the distance between the Earth and the rocket increases. As a whole, the denominator increases, so the gravitational pull also gets reduced, right? So most of the weight is fuel, such as liquid, hydrogen liquid. Rockets need so much of fuel in order to overcome Earth's gravity. Only when you reach a speed of 28,000 km per hour are they traveling fast enough to enter orbit. Most rockets are made up of two or three stages. I think you know those stages, right? That those fairings will be there to connect those stages, right? The payload case, the payload fairings will get. When a stage has used up all its fuel, it is separated to get rid of the dead weight. It then falls back, usually into the ocean and far from populated areas, or burns up into the atmosphere. Large launches often get an extra boost uh, from rockets strapped onto the first stage. This may use solid or liquid fuel they use, and usually thrown away. So Aditya, I think you were asking the question what fuel to use, solid and liquid. I think recently China has tried a mission of sending rocket using solid fuel. It has failed though, but yeah, that is one of the.
Uh, so, how is there any fuel?
Is there any? I missed the last question. What is that? Sorry, Aditya.
Like uh, I have heard about ion propulsion. Ion
Okay,
propulsion, is that the one?
I'm not too sure
Ion
what
propulsion.
what they have used the ion propulsion or not. I will find it out. But all I'm saying is that there is a way the solid fuels are also used. That is what I'm saying, trying to say. So not only liquid. So liquid means liquid hydrogen, liquid oxygen. So solid maybe. Hello. So the solid may be using the hydrogen ion in a solidified stage. Not too sure on that. Right.
Okay.
So that's the thing. Maybe I will just show another video on that, on a blast of a new rockets. Basically, this will give you a clear picture of how the rocket moves. So let me know, like, if it is visible or not visible in there. It's visible, right? Can you
So
see?
we can zoom.
Yes, sir,
We can zoom
visible.
in.
You want me to zoom in or zoom out?
We can
No,
zoom in. We can. We can. We can.
Okay. So what do you want me to
Explain.
I'll continue.
Yes, sir. Yes.
Okay. Good. Okay.
yes, sir, please explain the each part.
Okay. So these, if you see, these are the rockets. This is the first stage. This is the second stage, and this is just a case for this. And there will be fairings which is attached to this rocket payload fairings. So if you see this one, these are the boosters. So all I'm trying to say, uh, can you see my mouse moving?
Yes, sir.
Okay. So these are boosters.
Yes,
Booster
sir.
rockets. This is a booster rocket, right? So this is the first stage. This has a cryogenic. This has a cryogenic engine, and this will be detached when the rocket reaches a particular stage where the remaining the second stage rocket, this one can take it forward. So this second stage will go and put this satellite, like you can see the blue one, this satellite into a lower orbit. There is another
Yes.
engine is there, which is another satellite is there, if you see here, which will put at a higher orbit. So first this rocket, the one in the stage one, will be discarded along with those boosters, right? Then the second stage will be discarded, which will put the rocket, I mean the satellite, into the lower orbit, and then the first stage will take the rocket to the next higher orbit. Just see this video. I mean, you will understand how it is working.
Uh, uh, that speaking of the engine and this detachable, this type of, uh, we have a problem, sir, because after this engine will be thrown, it won't be of any use. And what about engine which is rebuilt?
Engine will be
use
no,
use
but
use it.
you have to collect the engine, right? Because it will be left off. Just see. I mean, wait a second. I'll take your question. Just see how the rocket is launched. Basically, can you see this thing, right? So I'll start again. Yes. Wait a second. Why I cannot make full screen? I don't know why I cannot make full screen. Let me see how we can show it better. My screen is visible, right? Yes. Screen is
Yes,
visible.
sir.
Okay. Okay. Fine. Yeah. See, the rocket is going now. See, it will detach the boosters and the first stage. See, it has detached the boosters, and the first stage is still there. Right, the cryogenic engine is in the end. It is going up. Now it has the fairings are detached now. Right now, see it has run out of fuel. The first stage has run out of fuel. It has detached. The second stage is going now. Okay, right. So the second stage is going. Then it will also running out of fuel. Then it will detach the satellite. It will go into the orbit. Right. Then this engine will start. This will now take it into the higher orbit, basically. So previously it was in orbit, lower orbit. So you understand the PSLV and the GSLV, right? There are two differences between PSLV and GSLV. You know that?
Yes, sir. Yes,
Yeah.
sir.
One is the polar satellite launch vehicle, and another the lower orbit. The other one,
Yes, sir.
yeah, on the GSLV, right? So can you see that how that rockets are launched in stages, and there will be fairings, and they take the. So coming back to yeah, I know you guys have a lot of questions. I'm giving just introductory session to make all of you in the coming to the same page, and then as and when we'll be discussing more in detail. I think for the space group, Oscar, it will be better if we can create a group where it's not. Don't make it like only admin can post messages. Let Aditya, Vicky, and sorry, Sorik, and who else is talking? I just now somebody said yes, sir. Uh, I know Sorik and Aditya was talking. Is it Rinky
Sir,
or you? Who are you? Sorry.
sir, I too want to join.
Oh, you also want to join? Okay, fine. Yeah. So I will ask Bhaskar to create a closed group where everybody can post messages. And so because I want to see, I can just only get you the information. I am just a messenger. I will collect the information and get to you. It is
Sir,
you have to collaborate.
I'm Sri
Just
Bhattacharya.
just a moment. Yeah, yeah, sure. I got your name. Yeah, I got your name. So I like you guys to collaborate more, launch collaboratively. You discuss among yourselves. Try to do research. Both of you to. I mean, all of you together, right? And then I will also try to get as much. I will also along with you. I will make the research because this is not my field actually. So I will do research. I will get connected to people who I know in ISRO or in maybe in other places, right? Okay. And I don't have any friend in NASA, but I know people in ISRO as well as any of academic side. So I will also connect to those guys if they have any questions. Yeah, we'll try to solve those together.
So, sorry, sir, we bothered you that.
So just to end running over. Yeah. Say that as
Sorry,
well.
sir. Sorry, sir, we bothered you that much.
No, 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 not bothered. You have interested me. Come on. I mean, see, my son is equally. I mean, just I will introduce him. Hey, Dogun, you go for it. Can you introduce yourself?
Hi, I am Saurajit Chan, and I'm 9 years old.
Which grade
Hey,
you
young
are?
man.
And I'm in fifth grade,
And you have
and
interest in space?
I know a lot about space, like the GSLV Mark III, PSLV, satellite launch vehicles, then moon base, Mars base, then what else? Yes, space elevators, etc., etc.
Yeah, good.
Same
Okay.
here.
Yeah,
That's
good, good,
great,
good.
buddy. Thank you.
Yeah. So, I mean, it's a really of interest, especially after the Chandrayaan 2 thing, and especially a lot of recently there is a Elon Musk has recently launched the
Yes,
idea of a commercial thing
yes,
how can be moon, and even I have there is a habitats in moon. I have in the my senior academy challenge there. How can we make the moon a habitable for human beings? So I am looking forward you guys to come forward and also we do more towards experimenting and making challenges. We have our own ideas. And recently there are talks going on that even India may ISRO may open up for the private players to come into the space. So there is a lot of opportunities come for space research. And this the mystery of universe is it's a like even if you have what I'm saying maybe 1,000 hours a day and you continuously run and learn entire your lifetime maybe you will just knowing a tiny molecule of the entire universe. So especially if you have seen the movies Interstellar and all those things, it's a nice one. I ask you to guys to look into those movies. And research is really, I mean, space research is really one of the fascinating chapters. Now, I would like to honestly, I don't know that much on the space. I know overall what I'm best about what to go science division. Definitely, I will try to learn along with you guys and help you out so that we can do something at the end of our endeavor.
Sir, I have a question.
Yeah, sure.
Sir, the website you are opening, you are typing gravity assistant, that all you find, your many topics are there. Sir, what is the website? Can you send in WhatsApp group?
Sorry, I didn't get you clearly. Can you repeat again? Can you talk slowly, slowly?
Sir, the website you are opening to you are typing gravity assistant, other things. Sir, what is that website? Can you send us?
Oh, okay. You want this website? No, I can send it. It's like it's called ESA. Okay, this one you're talking about, right?
Yes, sir, the website.
You want the website,
Sir,
right? Which one you're talking about?
Yes, sir.
sir,
In the website you are typing.
Sorry, I could not get you clearly. Sorry, yeah.
sir,
Yeah, who is Anshu? Who is talking? Sovik, I haven't get. Can you type in the message? Can you type in the chat box?
sir,
Yeah, tell me.
sir, I am leaving because my mobile's battery is 3%.
Okay. Go ahead, please. No issue. Sovik, can you type in the chat box? Yeah. Tell me. Tell me, Anshu. I can hear you, Anshu. Tell me.
No, sir, I am not telling.
Oh, then who is saying? Sorry. Oh,
Sir,
Ashok.
my name is Tuchi.
Oh, your name is Tulsi. Okay, sorry. Okay, then Ashok, you are saying something. Ashok, you are saying.
Uh,
Oh, they have not replied you yet. Wait for some time. Maybe they will. I think they will definitely reply. Wait for some time. They will read it and then they will reply, I believe. Yeah, and Sovik, you are talking about some website. What was the website? Typing gravity assist. Okay, that website. Yeah, sure. That's this one basically.
Sir, did you get me?
Yeah, I got you. I'm giving the website in the chat itself. I'm replying to the chat.
Okay, sir. Okay, sir.
Have you got it? So, Sovik, which class you are in, and which?
Sir, I am in class 7S.
Oh, 7. Okay, good. Good, Bhaskar. I think I will end the session now. Any questions we have? Better, Bhaskar, have a offline group for this, so that we can discuss more in details. Anything if anything interesting comes out. Especially Aditya's have a lot of questions, and I think who who asked a question about the red giant and the super red giant. Uh,
Yes, I have few questions and regarding robotics also I have
Sir,
few
I,
questions.
sir, I.
no, okay, great. So, yeah, Aditya, robotics, I will not go now. First, I will cover up this space, and we are in a let's be in a little bit comfortable position to understand something and make a together all of us whoever are here and this as of now together if we can make a good progress at least in terms of learning. I'm not saying like we have to deliver something, but we learn to an extent where we know quite a bit of things, quite a bit of, I mean, so many unknowns. If we can clear up some of the unknowns, right, that will
Right.
do. So robotics, maybe the next session we'll talk about robotics because few may be interested on the robotics part itself. And put your, so all I'm saying is that from the next session onwards, right, maybe I will continue with the space session again. If you can forward me your questions, what exactly your questions are, then I can get the answers and have those answers ready rather than saying, okay, I need to look into it, I will come back to you. So it's a little bit annoying. Can you forward me your questions beforehand, before the session, say at least 2 to 3 days before the session, so that we can have all the question answers ready. Right? We'll discuss
Okay.
together. It's not that I will answer the questions, but we'll discuss together. Maybe you will also guys know much more than me. Yeah.
Okay.
Yeah.
Sir,
Uh,
the
Yes,
website
sir.
for this, can you please give it in the WhatsApp?
I'm sorry.
Sir, sir, can you please give it in the WhatsApp, this website address?
Or this you want in WhatsApp? Okay, I will give it. I'll
Yes,
give it to
sir.
you.
You
I'll give
can
it
use
to
it.
you. I will give it to
Thank
you.
you, sir.
can we form WhatsApp group today, if possible?
Yes, sir. It will be better if today we will get a WhatsApp group.
I it depends on Bhaskar. I will give the authority of Bhaskar to create the WhatsApp group because I don't know exactly your number and name. So Bhaskar will have all the details. Bhaskar will do. He said he will do. Okay.
Sir, I also want to join there.
Sure. Oh, what is okay? You are not Anshu. You are Tulsi, right?
Yes.
Okay. Okay. Yeah. Actually, whatever your name comes with the good Gmail, I think it's your parents' name. Hmm.
Yes.
Okay. Okay. Anubhav is also interested. Yeah. Whoever is interested, ping Bhaskar sir. Bhaskar sir will send you everything. I mean, he will make you join, or maybe he can create a link and ask everybody to join. But all I'm looking for, if you are joining there, it's I will make it a kind of. I will look forward, Bhaskar, that you make it more of a open group. Not everybody can post, but everybody's participation is required. If you just don't be a listener, I want everybody to be contributing, everybody giving, contributing, not like copying a link and pasting it. Give your thought, give your discussion, write in English text, right? If required, write in something in the Word document. You put your questions in a Word document, whatever the studies you have done, what are the new things you learned today, which you feel worth sharing along with your peers, right? So that kind of things. And so I will try to say like devoid of any kind of forwarding messages, like for example, there are a lot of other contextual forward messages come. Try to
Yes.
try not to do that. Just keep the context only to the space
Okay.
technology. So this is only for the space technology. This will not deal with any kind of IoT nor with any kind of robotics.
Okay.
Right. All right.
Okay.
Thanks everybody. Have a nice day ahead and stay safe. Stay safe and healthy at home.
Okay. Thank you, sir.
Thank you,
Thank you.
sir.
Have a nice evening.
Thank you, sir.
Thanks. Bye.
Mr. Sorry for the
Yes, anybody
Mr.
called?
Sorry. Yeah,
Yeah, yes, sir.
I I see. Can we have a WhatsApp conversation?
Yeah, sure. Well,
Okay. I guess in group we will share the numbers at that time in the group.
yeah,
Would
yeah,
that
yeah.
be
No problem, no problem.
okay? Thank you.
Thank you. Thank you.
Goodbye.
Bye.
Stay safe, everyone.